Hey everybody, General Scar here, and today I wanted to go over a pretty simple building generator that I made in Houdini that basically takes in a group of shapes and then just builds out I guess you say like a full representation of a building. And basically I made this as an HDA for a game I'm working on in Unity, so I can use Unity Engine to basically quickly create playable buildings. So what I mean, it has like interiors in here, and it has the floors separated, and I can, choose how many floors I want. It's got inputs for which shapes I want to be using for what specific features. I can set the height of the floors. I just have it set to 2. I can choose number of floors again. I can set materials, and it all set that up inside of Unity. Here's a quick video showing a little bit about it, or at least showing how it works inside of Unity really quick. But I wanted to go over a few of the techniques that I used. I'll go over sort of the basic flow of the whole thing, and then I want to go over some of the specifically like 3 different sort of stuff techniques I used in these, including getting a primitive, like selecting a primitive nearest to a point, setting up the UVs in a way that they're all oriented properly, and also applying scripts to objects being built through Houdini Engine. So you can, when you make something and you use that tool inside of like Unity or Unreal, you can apply a script to the object that's getting created and even like run a method with like a string parameter, so you can actually just set it up in a specific way too, which is really cool. So I'll go over that as well. That lets me basically build this out, and then it's already fully playable inside of Unity without having to do any extra setup, which is super nice. So, first of all, it is an HDA. It is an object level HDA. I think you have to do this now. You didn't used to have to do this for Unity Engine. You could do like inside of a geometry node, create a HDA, but you kind of have to do it out here. But that's good because this lets you have, it's good and bad. You have to have specific objects like this created to have them show up, uh, instead of some stuff like before you could like split by a group, and then you could just sort of procedurally create more geometry and different groups, and so you could have a bunch of different objects depending on what's in there. This one you kind of have to have a set maximum. This has 5 floors here, but anything that doesn't have geometry doesn't get output. I don't know if these are set up. They are, but they're probably not updated to what I have. So if nothing is coming out of the nodes, then they're not going to get, it's not like it's going to create an empty. It won't create an empty. So it's whatever geometry is being created, that's only what's getting output anyway. So you can just have as many of these. I decided to just have like a max of 5. I don't think I'm going to go over 5 floors for something like this. And if I do, then I just make another building or something. And a roof. And each of these is inputting, is getting an object merge from this base geometry node, which is doing basically all of the work. And then I'm just like at the end splitting out into the different parts of geometry that are going to get put into the different object nodes. So there's a lot happening in this for loop. This for loop is basically for each floor that we have set up. And then the stuff over here is on the right. This is the roofs. Right now, there's like 2 things. I don't have an option to switch between them. I'm still sort of working on this, but there's, this roof, and then I wanted a more walkable roof as well. So I want to add a feature where I can set roofs to be walkable, like a balcony or something, instead of just being always this. But we'll see what happens for my purposes. So let me go over the geometry that's getting input into this first. You can sort of see this is the base shape of the actual building, and that is defined. I'm using it inside of this node because this was an old test one here. So this is just boxes and tubes. This could be basically any shape that you want. It works best if it's locked to the grids. So I found that that's important. My game is, the movement is locked on a grid already, so that's, perfectly fine for my uses. Also, because the way that I'm building it out, it is based on grids, because my game is based on grids, so everything being on grids is kind of important anyway. The next one is doors. So these are just geometry that tell you where to put the doors. So if I open this up again, and then you can see there should be a door there. There should be a door there and there. This is the new input shape I'm using. I was using this one. Oh, yeah, that has to do with like selecting a primitive from points, you know, the nearest primitive to a point. I was using a different method to select which primitives to delete for the doors before, where I was just like using a bounding group, but that just kind of a pain actually in Unity to set up specifically because you don't know exactly where stuff was and you have to specify shape, blah, blah. It's just too much work. Finally, there are stairs geo. This is basically the same thing the doors are doing, where they're just like putting holes, except they are doing it in the floors. So you can like put a stair piece there or like a ladder or something to move between floors. It doesn't automatically add stairs and stuff like that. That's just going to be a prefab inside of Unity that I can set up. I think that's going to be the easiest way. All of the interiors are going to be set up like inside of Unity with prefabs and maybe just like pro builder walls or something, because I think that's just a bit easier. Just getting the basic shape of all this is really good. I'm gonna turn on roofs again. I have, if you right click on a node and you go to parameters and channels and hit parameters, you'll get this nice little pop-up window of all of the parameters. So you can just have that off to the side somewhere instead of having to like, especially if you're working with like asset HDAs, having to always go back to the thing here to copy and paste or change values here inside of the thing. You can just have a separate window. Again, right click, parameters, super handy. So let's just go into the nodes here. So yeah, first we get the shape input. We're bringing in the different geometry in different parts as we need it. So this main for loop is basically running for each floor that we have set up here. Come down here, I think it's set up. Yeah, our iterations are set to our number of floors. And it's, you know, taking our geometry, clipping the bottom, clipping the top. This is doing the third floor. So let me solo a floor here. I have to come out of the for loop for it to update properly. Okay, so now we'll just look at the first floor. So we come in with our geometry, and then we'll clip the top, clip the bottom, clip the top. So we just have this one section of geometry that we're working with. Polyfill to give it filled in, so we can boolean it with a grid basically, and this is just the floor. This grid scales with the bounding box of the clip node here, so it should always be the right size. And so we just get a nice grid. We divide the floor. We get rid of the shared edges. So we just get a solid polygon. We use a facet node to get rid of inline points. So I don't know if it shows up in this one exactly, but like if there's a lot of points along a single straight edge, the facet node will get rid of it, which is really nice. And then we divide it again but we're using a bricker this time. So it divides it into a 1x1 grid. And this is very useful for blasting out the floors and also setting up the walls. So let's go to let's just do the floor first. You know, we're just UV mapping it, getting the closest point from our primitives, which is our stair objects here, and then blasting them, which I'll go over with the doors because you'll be able to see that. And then we just use this to set a material to the floor based on the names that we have set up in the tool and also the floor. So there's a different material for like the bottom floor and another one for any other floors. And then we group it so we can split it later. And then we just merge it in with the walls. So then for the walls, I had to do this thing where I have to set the point normals to 1 because sometimes when you do like the divides and the booleans, it has some wonky normals. So this just helps get rid of any weirdness when I'm extruding it. So I extrude it up. I only extrude the sides, so I just have the walls. And then I use this closest prim from points, which is a custom wrangle. This is a detail wrangle that basically takes a set of points, which is our door geometry here, which we, I'm not sure if I need this connectivity anymore actually, but oh, I might. We extract the centroid here and we do it per class. Yeah, so we do need that. So this is setting up each piece of geometry has a specific like identifier, and this extract centroid is able to take each individual one of those groups of identifiers and get the center point of each of them, which is super cool. So now we just get points, and we put that into this wrangle, and this uses an XYZ dist function, which one of the things, this num is an out for a primitive number. So this will give you the number of a primitive that is closest to a given point, which is center here. And then we can set the search radius as well. So I think it's only searching within a radius of 0.5. So the doors actually have to be, geometry actually has to be close enough to a door for it to work. So if there's just like a random piece outside somewhere, it's not gonna, just still get rid of a primitive when it shouldn't be. So then we just add it to a group for door blast, and then we blast the doors. So as you can see, we have next to our doors, we have the doors gone. This took, it wasn't too hard to figure out, I guess. This was very nice to know. I think I've needed to do something like this before, but never really got around to it. But this is a good way to do it. And then we just extrude it out, or in, technically. I think I'm going to change this to be out so I have more space on the inside of buildings. Reverse it, set the normals, and then we just clip the bottom off. So you're not going to be able to see these faces anyway in game, so might as well get rid of it. And then we do this whole long stack of UVs. Oh man. Oh, and this closest primitive to point thing, this is basically what's happening over here on the floors as well. You can't see it here because it's the first floor, but it's the same thing. It's just active working on these floors instead of on the walls. So yeah. So first we group our seams. So we auto seam. This is to prevent some issues with like the tubes. And then the UV is not getting cut all the way. We just add an auto seam, and then I add a group on the edges just to get edge angles and basically have seams based on angles. Then we just get bottom edges, and this is important for our UV flatten. So we take this group, which is edges, and then we have to promote it to vertices so we can use it to align our UVs inside of our UV flatten. So this first UV flatten, we don't use that. This one, we're actually doing 2 UV flattens because this process is a little complicated. But basically what happens usually is you'll flatten it out, but then sometimes the UVs will be like sideways instead of the direction they're supposed to be. And you could use, where would it be? Here, vertex alignment groups. So I could set this to have the bottom edges. But now the problem is sometimes they're upside down and sometimes they're still sideways, which is annoying. So we're not going to use that. Instead, then we UV layout and we lay them out based on their island position in 3D. Which basically can help, but doesn't always work. And then we get a connectivity, and the connectivity node is, you can add a UV connectivity, so it loops over every single UV shell instead, which is really nice. So then we go through a for each over a class attribute, similar to how you would do like a for each object, for each connected piece, but instead of using primitives, we're using the UVs. Excuse me. And then we do another flatten node. And then this time we do use the bottom edges. So we're basically like re-flattening out the UVs. And then there's this whole thing here, which is basically checking if the UV is upside down or not. So this UV flatten should sort it out to where nothing is going to be sideways. And then this wrangle here is going to be basically be checking if it's upside down or not. And the way that it does it is it checks first. We have this sort up here, and we sort our points by primitive order. This is awfully complicated, and it was annoying to figure out, but it's going to sound kind of simple. But so all of our points basically indicate the primitive order of our UVs. So we can have like a 1-to-1 if point 0 is basically going to be the same spot as vertex 0, and the vertices hold the UV information, which we're checking with the point information. So we get a list of all of our UVs, we get a list of all of our points, and then we basically check if point 0 is the lowest point. So if it's below or if it's above. It's if it's on this bottom row or if it's on this top row. That's basically what we're checking. And then we set a 0 at bottom, which we're using basically as a bool, even though it's set as an int, but bools and ints are kind of the same thing in Vex. Then we go for a same thing for the UVs. We check if UV0, if the UVs for vertex 0 up here are at the bottom, and if the 0 is at the bottom, then it's fine. Basically, this is checking if the UVs, if 0.0 isn't at the bottom, and then also if the actual position of the point is at the bottom, then we know it needs to get flipped. So we're basically just checking the height of the point compared to the height of the UV, and if they're relative, like if they're up or down and they're the same, then they don't need to be flipped. But if they're different, then they need to get flipped. So that's how I figured out how to get them to all be lined up the same way. And then we just like put that attribute into this switch to switch between flipped UVs or normal UVs. And then we just pop it in there. We do a texel density. And then one other thing that I wanted to do was have, because I'm using procedural textures, wow, that's a mess. I wanted them all to be lined up in basically the same corner so that the textures all tile very similarly to each other. I have the way that I have my textures set up, they're like pixel textures, so I want them to look nice and crisp and lined up well. So the way that I did that was I just, again, went through each UV shell and UV laid them out individually. The biggest problem here is that they're at going down in the UV space when I want them to sort of start here and go up right instead of down right. But I can probably just add another little wrangle for that too. Shouldn't be too hard. But then yeah, so then we set the wall material. Again, based on if it's the first floor or not, we can have different materials. We set its group to wall so we can split it out later. And then we will merge it. So we are merging the walls and the floors. This is setting a specific value for the floor. I believe it's a detail. Oh no, for its primitives. So each primitive here will have an int attribute saying basically what floor it is, and it's just based on the iteration of the for loop. So once we have all of them, and we just have them all out here, basically these primitives down here will have 0, the ones up here will have 1, and these will have 2, just as a way to be able to split them out later into the individual floors. And then we just set up normals, a partition node. Yes, this is the one that creates the groups. So this partition node will create groups based on the floor. So I think if we go this button here, yes, we have group 0, 1, and 2. So that's how we can split them up later. And then we merge it with the roofs. The roofs are pretty simple. What's the one that I had turned on here? There we go. Just go over that really quick. Just for this right one. Basically, we take the input geometry here. We clip the top based on the height. We polyfill it. So this top clip is basically the same as this top clip here. Just so we're at the proper height. Polyfill it so it's whole. And then we do a Boolean of this original geometry against one where we take the top faces, we blast everything else, we Boolean them together in case there's like some overlapping faces, we divide them and we get rid of shared edges so we just get flat shapes, and then I just poly extrude them up and add a bit of a curve with some spine control stuff, add a few divisions to it so it looks nice, and then yeah, just Boolean it against that original shape so it fits basically perfectly to what shape we had. And then for some UVs, group the top edges, promote those to edges. This is using normals, keep by normals primitives. So any normals that are facing up. And then just turn those to edges. So those are some of our UV seams. Normal node, I probably don't need that there. But then an auto UV seams here. And we include those edges, those seams we made earlier with this group here. And then just flatten it out with those seams, texel density, and then layout. So we get some nice, generally nice. There's some exceptions with this. The shapes are kind of weird, so it's a bit unpredictable how exactly the UVs are going to turn out. But generally this gives a decent enough straight representation of roofs, or it did. I don't know. I'm still figuring this stuff out too a little bit. But then we just group the roofs, and I have a switch there for later. And then we set the roof material, and then merge it all together. And then we just split it out into the different ones. So we got the roof, we got the first floor, second floor. Let me turn off these primitive numbers. I'm going to show you these. Third floor, and then if we had a fourth and a fifth floor, those would export out too. Then those go into these individual object things, and one nice thing we can do with these objects is have like the individual scripts on the objects being created. So you'll notice that I have a floor 2 and I have a floor 2 art, or floor and a floor art, floor 1. The difference being one of them is basically a trigger, the other one is the art and collider. So I have a script that basically when the player walks into a trigger zone, it will tell all the objects in the world listening to it that, hey, the player has entered into floor whatever, and we can set the specific floor for whatever the trigger zone is. So when the player enters into this building down here, it'll say, hey, the player's in floor 1. So then I have another scripts that will hide themselves for the different floors depending on what floor the player is in. So for example, floor 2 art here will hide itself when the player enters into the first floor so that they can see inside of the building. And all floors above floor 1 will do that. The roof is set at like floor 100 or something like that, so it'll always disappear when you go inside of something. So I have 2 different scripts. I have 2 different colliders to set up and basically all that stuff. So I take in the geometry to begin with, and then I will add a attribute wrangle here. So there's this Unity script here, attribute that you can add that lets you add the attribute. So for example, the script is called view floor trigger, and then you can run a method and pass through a parameter, a single string through as well. So I'm applying this script to this object that's being created, and then when that happens, I'm running this method with this parameter. So I'm setting the floor number to 1 when I add the view floor trigger to it. And then I'm setting the layer to the player triggers layer, so it'll only interact with the player when they're walking in and out of it. And then I set the mesh to, I add a group, and this will add a collider to it, and you can have different colliders depending on the name. There's like a whole list in the Houdini Engine Unity documentation you can find. Basically, setting up a convex collision trigger geo. The biggest problem with this right now is that it does not work well with concave geometry. So for example, if I do, it's going to make the collider convex. So if I add a shrink wrap, it'll basically show you what it looks like. This is what the collider looks like. So there's this, if I can hit the right button, little spot right here. If the player walks into this little corner where there's no building or anything above it, it'll still activate that they're on that floor. So I need to figure out a way to have some form of like boxes laid out inside of here, or because Unity doesn't support concave or non-convex triggers, which is a little annoying. So this is the best that I can do for now. I'll probably try and find some better solution later. But then it just, yeah. So then when it exports, it'll turn this into a collision mesh inside of Unity. And then for the floor art, we just take in the same geometry that the other node did, but instead we add a different script to it. So we set building floor scripts, and then we run the method to set floor to 1. So we can set this floor, we know what floor this is going to be set to. And then I set it to static because I was using Unity's nav mesh, and you need stuff to be static. So I could just like build it and then hit build a nav mesh. I'm still working on my nav mesh solution, but that's what I got for now. And then add the group for rendered collision geometry so that the walls and the floor will have collisions that I can like raycast against and stuff as well. And then export that. And then you just do that for every individual floor. And the roof is pretty similar, except it doesn't have this. It just has the art. This doesn't have any colliders, so you can't walk on it. So we just set the building floor height to 100. And yeah, so you just like build a bunch of shapes, and you can just stick it in and it'll make a thing that you can just walk around in like automatically, and it's super nice. So hopefully you could have learned something new from this. There's a few things I've certainly learned that would make making stuff in the future possibly easier depending on what it is. But yeah, thanks for watching.